Hi there, my name is Rachel Agarwal and I will be briefly talking about geothermal energy and an analysis on its impact and technology. Let's start by a brief introduction. So what is geothermal energy? Geothermal energy is all around us. It refers to the thermal energy generated and stored in the earth. It is an inexhaustible source of renewable and clean energy. One of the unique advantages of geothermal heat is that it is found everywhere on the planet, and depending on the application, it can be accessed through virtually anywhere on every continent. Thus, anyone can take advantage of this energy regardless of the conditions on the Earth's surface, such as weather, which solar and wind heavily rely on. Now we know there's a lot of energy beneath us, but the question we need to ask ourselves is how can we use it? Geothermal energy can be utilized directly, which implies using it as a direct source of heat, or it can be utilized indirectly, which means that we can use this heat and generate electricity from it. Now let's take a moment and talk more about using geothermal heat as a direct source. There are a few applications which uses geothermal energy directly. For example, district heating, greenhouses, and industrial process heating. And just to be clear, when we talk about using geothermal energy directly for any application, it's usually related to low geothermal energy, which means 149 degrees Celsius or less. Some traditional methods of utilizing this energy are through hot springs or geothermal reservoirs. Since this method requires a geothermal source in your proximity, another method developed to utilize this energy directly was the heat pump. So, what are the heat pumps? Heat pump is a device that extracts heat from one place and transfers it to the another. There are a few different designs available for these. For example, direct exchange system or a closed loop system. However, I will not go into details of how these heat pump works because that is not the focus of this report. Let's move on to the next topic, which is using geothermal energy as an indirect source, which is the topic of interest today. In order to generate electricity, we need a geothermal plant, and there are a few different kinds of plants. Let's just start off with the basics, which is a dry steam plant. Dry steam power plants had their debut in 1904 and were the first type of geothermal energy conversion plants. At its most basics, dry steam power plant produces electricity directly from the steam that comes up from the ground. These plants require the steam to be very hot, or in other words, these plants require an operating temperature of 150 degrees Celsius or higher. The steam is brought up by the production well and redirected to a turbine which drives a generator which produces electricity. After the steam is condensed, we can use the re-injection well and put it back into the reservoir to sustain its life. The following diagram displays a basic layout of a dry steam power plant. You can see the production well on the left, from which the steam is brought up and redirected to the turbine, and later on condensed and put it back into the reservoir using the injection well. That is the basic layout. Let's just move on to the next steam plant, which is a flash steam power plant. A flash steam power plants are the most common type of geothermal power plants in operation today. They were made popular in the 1950s, especially by New Zealand and their vast adaptation of this technology. This plant utilizes the same basic principle as the dry steam plants, but with some modifications. A flash steam power plant works by using the water which exists as a compressed liquid under Earth's surface at high pressure. This water needs to be at least 880 degrees Celsius in order for the system to work. This water is then brought up by the pipelines and production well, and it is shot into a cold environment which, by sudden change in pressure, flashes the water into steam, at least most of it. After the steam portion of the process is redirected into the turbine where the power is produced. The steam is condensed back to liquid form, and along with the hot water left over from the previous process, it is temporarily stored where this hot water might be used for some other heating applications before being re-injected back into the outer limits of the reservoir. The next diagram shows a basic layout of the flash power plant. If you remember the diagram from before, it is almost the same except the flash tank, which is located on the bottom left, where it says steam and brine. That is the only difference between a flash power plant and a dry steam power plant, for example. Let's move on to a binary cycle power plant. Binary cycle power plants are the latest technology to convert geothermal energy into a usable power source. Even though the binary cycle power plants use turbine to generate power, they are still very different from the above two mentioned technologies in many different aspects. A binary cycle power plant uses a closed loop system, which is a key factor in differentiating this plant from others. This plant uses two fluids instead of one, like the others. The primary is the geothermal fluid, and the secondary is a fluid with much lower boiling point than the water, for example, isobutane. Once the geothermal fluid and the secondary fluid passes through the heat exchangers, the heat from the geothermal fluid causes the secondary fluid to vaporize, causing the turbines to turn. The steam from the secondary fluid is condensed back into liquid form to be used again later. Just to be noted, the heat exchangers efficiency, or in other words, the thermal efficiency of this plant is 10 to 13%. Well, the two biggest advantages if you use the system is that you can use low to moderately hot geothermal fluids. That means you can use the fluids which are under 150 degrees Celsius in this plant, which is a big advantage. And another advantage is closed loop system, which implies that there is no emission released into the atmosphere. Now, let's just take a moment to really compare these three systems side by side. One thing that stands right out is not only what differs, but also what is similar in these systems. All three of these systems use production well and an injection well to bring the steam up and to re-inject the steam back in. However, there is another similarity, which are the turbines running in these systems. They all use the same steam turbines. So what is a steam turbine? Steam turbine is a device which uses thermal energy from the steam and converts it to mechanical work, which in this case implies the mechanical work is a rotating shaft which is directly connected to an electrical generator. The efficiency of these turbines can range from 10 to 37% depending on the conditions the turbine is being operated under. And that is just the basic diagram of a turbine generator. And as you can see, the turbine is connected to the generator, which finally produces the electricity. Moving on, let's talk about some of the benefits of geothermal energy. The key benefits are this technology is cost effective over its lifetime. So what does that mean? Well, looking at this diagram, we can see levelized cost of all different types of power sources, and geothermal energy is fairly cheaper than the rest of them. This diagram does show the energy in megawatts hour, but if you calculate in kilowatt hours, geothermal energy calculates to be about 5 to 10 cents per kilowatt hour, which is much cheaper than the rest of the technologies. What are some other benefits of geothermal energy? It is renewable and a clean source of energy, and also it's reliable and does not fail. However, with all these benefits, there are a few limitations to this technology. The main two limitations are the upfront cost of this technology. And what do I mean by that? The main initial investment you have to put in order to start this plant is quite high and does not guarantee a successful plant. There have to be $1 million spent in order to find a suitable location for the plant to be built. And on top of that, the drilling success rate is about 80%, which means you do have a 20% failure rate even after discovering a suitable location. So there are some financial risks which limit the use of these technologies or limit the wide adaptation of these technologies around the world. So as a quick conclusion, I would like to add on top of the benefits mentioned that geothermal energy has great potential. This versatile energy is not only being used to provide clean and renewable power in form of electricity, but also in form of direct heat. From the first geothermal plant in 1904, this source of energy has withstood the test of time and has proved to be a serious contender for one of the major future power sources. And that is all I have for you today. Thank you for watching and have a good day.